I'm kinda confused. I wish there was someone who could help me with this lab.
The purpose of the lab is to analyze qualitative and quantitative results of the double displacement chemical reaction of potassium hydroxide that reacts with copper sulfate to produce copper hydroxide and potassium sulfate. Before starting this lab, we first need to balance this equation. You can do this by placing a 2 acting as a coefficient in front of potassium hydroxide. This makes sure that no extra matter is created or destroyed.
Come on, man! That's too easy!
This part of chemistry is known as stoichiometry, which is the study of quantitative relationships between reactants and products based on the law of conservation of mass. The law of conservation of mass states that matter is neither created nor destroyed, however it is transferred. For this lab, you need to figure out the limiting reactant. The limiting reactant in the equation is the reactant that controls the amount of product produced. In this equation, it controls the amount of precipitate that will form. Here's an example of a limiting reactant. To make one king, you would need 1 LeBron and 1 James. If you have 15 LeBrons and only 10 James, then you can only make 10 kings because you run out of James. This means that James is the limiting reactant, making it so there is a limited amount of kings formed in the equation. The limiting reactant in this equation controls the amount of precipitate. This is the solid formed below the excess liquid, which is called the supernatant. This is the excess liquid above the precipitate. Let me know if you need any more help with this lab.
What we used to measure was the burettes for the copper sulfate and the potassium hydroxide, a graduated cylinder to measure the water. We also used 8 test tubes to put each liquid into. Then we used a stirring rod to mix the liquids thoroughly together. We then cleaned each material and began our lab.
In trial 1, Mr. Mitchell added 50 milliliters of 0.1 molar copper sulfate solution into one burette. The copper sulfate was a blue liquid with no smell and no density. Into the other burette, he added 50 milliliters of 0.2 molar potassium hydroxide solution, which was a clear liquid with no smell and a very low density. Next, we dispensed 5 milliliters of copper sulfate into each of the test tubes. Then we added 1 milliliter of potassium hydroxide to tube 1, and then we put 2 milliliters into tube 2, and so on, increasing by 1 milliliter in each subsequent tube. Afterward, we filled each test tube with water, bringing the total volume in each tube to 13 milliliters. After we thoroughly mixed the contents of each tube, and then finally we allowed for the test tubes to sit for 15 minutes to let the precipitate form.
During the 15 minutes, test tubes 1 through 4 began to form a bright blue, powdery solid at the bottom of the tube. This was the copper hydroxide with a clear liquid above, being the potassium sulfate. In test tubes 5 through 8, the blue liquid became a darker green, but no solid was forming. Then, we measured the precipitate. There was a gradual rise of precipitate from test tubes 1 through 4, from 4 to 28 millimeters, and then there was a leveling off from the test tubes 5 through 8, going from 60 to 85 millimeters. As we let them sit even longer than 15 minutes, each test tube's powdery solid turned into a black color.
In trial 2, we got different results. The trial was less accurate. We performed the same procedure, but during the 15 minutes, we ended up with test tubes 1 through 4 being the same with the light blue powdery precipitate at the bottom, and test tubes 5 through 8 having turned a dark green, almost black color with no precipitate. The leveling off was also less consistent. The reason for the differing heights is because in test tubes 1 through 4, the limiting reactant was the potassium hydroxide, and so the precipitate increases with the amount of potassium hydroxide. This shows that potassium hydroxide is controlling the amount of product produced. In test tubes 5 through 8, the limiting reactant is copper sulfate, so the precipitate stayed constant with the amount of copper sulfate. This tells us that copper sulfate is now controlling the height of the precipitate. Our results in both trials were similar, with 1 through 4 forming a small, powdery solid at the bottom and a murky liquid above, and 5 through 8 staying completely liquid. In trial 1, our sources of error may have included the measurements of distilled water being off and not mixing test tubes 5 through 8 well enough. In trial 2, we think our main sources of error were not mixing enough and the test tubes not being cleaned properly.